That sounds like a rooster.
Hey. Come on.
Okay.
Thank you. Shh. Sorry. More than one computer in the office. Okay. Well, let's start with how far did you get? Trent and Edik, what do you want to go over, or do we want to just start part 2, or what do you want to do?
I was able to finish it, so I did. Yeah.
Yeah, I got to 3.
Okay.
So I can start with number 1.
Sure.
So I said if the parent population is normally distributed or if the sample size is larger than 30.
Greater than or equal to 30.
Greater than or equal to 30. Okay. Okay.
What number was that? What question number?
That was number 1.
Part 1. Okay.
Número 1.
Okay, and then for the z-score formula for a sample mean that is normally distributed, I gave myself 2 because sometimes it's z equals x bar, meaning minus mu, which is that mu.
Sorry. my wife's going to work.
So I like I said, I've got 2. Z-score equals in parentheses x bar, which is the mean of the sample, minus mu, which is the population mean, all divided by sigma, which is the standard deviation of the population, or it's the z-score equals x bar minus mu divided by, in parentheses, sigma divided by the square root of n.
Yeah, that's what. And I didn't know how to pull the symbols up on Word, so I just spelled it out. I said value minus the mean, or z equals a value minus the mean divided by the standard deviation divided by the square root of n.
If you go into the answer key, you can copy and paste the his version of the equations and move it into your notes.
Okay.
And I found some of the special symbols up at the top of Word. You've got the Home tab and the Insert tab and the Design tab.
Mm-hmm.
If you click on the Insert tab, on the far right it says Advanced Symbols, and most of the math symbols that we're using, the mu, the sigma, square root, is all in there under Advanced Symbols.
Oh, cool. I see the symbol right side. Oh yeah, there they are. Cool. You can either even have add a little TM.
Yep.
Cool.
There's all sorts of cool stuff in there. Okay, and Edik, do you want to do number 3?
Yes. Okay, suppose a normal distributed population has a mean equal 10 and a population standard deviation of 5. What is the probability a randomly selected individual observation is between 5 and 15?
So I was wondering how you calculate the
You got to draw it out. If you draw it out on the bell curve, all of a sudden you realize that 5 and 15 fall exactly on one standard deviation. And so if it's on one standard deviation, you hit that 68, 95, 99.7 rule. So it's approximately 68% or 0.68.
it's a section right in the middle between the two one standard deviation lines.
Yes.
Okay. Yeah, I was trying to figure
Because,
out how.
but you gotta, like I had to draw it out and all of a sudden, well, that was, because 10, and then if the standard deviation is 5, so 5 plus 10 is 15, and the standard deviation is 5. 5 minus 10, or 10 minus 5 is 5.
And 10 plus 5 is 15.
So, question. So if you have a one standard deviation negative, and can you have half a standard deviation positive?
What do you mean?
Like instead of, so standard deviation is, let me see,
It's
deviation is 10.
on both sides. Yes.
So what if instead of 15 they were looking for 12.5? Is that possible?
I don't know. We haven't gone there yet. I'm curious because at the moment, all of his, when
Yeah.
we have two numbers, they've all been equal. So
Yeah.
give it another 2 weeks or so and maybe we'll be playing there. But right now,
So
they're always equal.
Another way I saw the instructor like solve a problem was like he went and looked for the possibility of getting like less than 5, and the possibility of getting more than 15, and then he subtracted those two possibilities from 1, and the result is
that was farther down, and I think we had a little bit more. John.
Yeah.
Just a moment. I'm sorry. Somebody's at the door for you. Please go downstairs.
so does that make sense?
Yeah. He did that in like the last 3 or 4.
Yeah.
But I think for this one it would be more difficult to do. Thank you.
Yeah. I think
okay.
both ways work. So yeah.
What is the 40th percentile for this population?
I don't know. I'm trying to figure that out.
You have to open the applet.
And just type it.
And
I opened the applet and typed 40 into the area, and that gave me a z.
Yeah.
That gave me a z.
Sorry.
Yeah, and that gave me a z-score of 0.253.
So then you take because we're dealing with 2 different, so the negative 0.253 is for 5, and the positive 0.253 is for 15. So once you've figured out the z-scores, what?
Can you tie my shoe?
Yeah, that's kind of where I got lost. So once I have the z-scores, I just go backwards in the equation.
Yes.
Okay.
So negative 0.25. Okay, go downstairs and get one of your big. No, you need to walk away. Yeah, so negative 0.253 equals, open parentheses, x bar minus 10, close parentheses, divided by 5.
Hi, Mom.
And then solve algebraically.
Okay.
Do you want me to share screen for a minute? So you can see it?
No, actually, I'm just working it out real quick.
Oh, okay.
So 5 divided by the square root of the.
We don't have an n this time, so this is the simpler form of the formula where you're just dividing by sigma.
By the. Okay, yeah, because it doesn't mention a population.
It specifically says it's the population standard deviation is sigma equals 5.
So it's a simpler equation.
Yeah, where it's just the z equals open parentheses x bar minus mu close parentheses divided by sigma.
Okay, so I've got. So I'm going to multiply both sides by 5. Math.
Then go play. Not in our house.
3.
You guys need to go play.
Okay, so I've got negative 1.2565 plus 10 265. All right, so that gives me 8.735.
Yep.
And then
That's it. The 40th percentile is 8.735
and below.
for this population.
Okay, because that's the mean with the 40th percentile z-score in the equation.
Yes.
Okay. That makes sense.
And I just wrote down in my answer, find the z-score on the applet, 0.40 gives a z-score of, and then solve algebraically. So I remembered how I got to x equals 8.735.
Z-score of 0.45 in the applet.
0.40?
Yeah, 0.40. Did I say 0.45?
Yeah.
Okay. I typed it. Typed it right. Negative 0.25. Okay.
Excuse me.
Okay, what is the z-score for an observation of 18.5? So that would be the.
X. Or x bar.
Okay, that's the.
The sample mean or the
Yeah.
value, depending on what you want to call it. And then again, this is another simple equation without the square root of n, because we've just been given, so up at, what is it, 3. So open parentheses, 18.5 minus
minus 10.
Yep. Close parentheses divided by
5.
5. Yeah.
Yeah, I didn't catch on to the fact that the observation is x. that should have been a keyword, or that is a keyword, and that didn't quite click for me.
Well, what's been confusing is there's anywhere from 2 to 4 terms for almost everything. Yeah, so it is.
Yeah, I need to review my notes so I keep those fresh.
Words, yeah.
Yeah, because the equations get mixed together in my mind. So I got the z-score of 1.7.
Yep. How about you, Anetic?
Yeah, I got the same.
Okay, so then what is the probability that an individual observation is greater than 12?
Okay.
Two.
I started with finding the z-score for 12. Found the z-score of,
Equals.
yeah. So z equals, open parentheses, 12 minus 10, close parentheses, divided by 5.
Mm-hmm.
So the z-score is 0.4. I put that into the probability applet, probability applet, and then highlight just the right side because we want greater than 12. And it gives us a probability of 0.3446.
Do you understand the question, Trent?
Um,
I'm asking that because
What is
it
the
was kind of confusing for me too. But basically, it's the same thing as C. The observation is 12, and you have to start with the observation minus mean over standard
divided by
deviation.
5.
Yeah.
Mhm.
So basically observation and value, the X value or observation or the sample mean all mean the same thing.
Yeah.
Okay. And then if the z-score is 0.4, I plug that into
0.4
0.4.
on the right side bottom of the applet.
Okay, and then the area, the probability would be 65.5%.
No, because you only want the right because it's greater than 12. So only the right.
Oh, greater than 12.
Yeah, you have to make sure where you've highlighted is the correct. I did that like 3 times later on, where I had either too much highlighted or the wrong part highlighted.
Okay, yeah. So greater than 12 is an area of 35% basically, 34.5.
Only so far they want the probabilities always written in a decimal point. So 0.3446. And somewhere between 3 and 4 decimal places seems to be the standard requirement. That, and I've noticed we're not supposed to round until the very end. If we're asked to round, they don't want you rounding until you've found the answer and then round.
So it doesn't change.
Yeah, which makes sense because if you start rounding before you're done, it completely changes your range. There's the right word.
Yeah. All right, let me see if I can get 12 by myself. So I don't know why we're using the simpler equation whenever we studied the more complex one in the textbook.
We used the more difficult one farther down. One of the things I noticed is that an N will be in the question. That kind of helps trigger that I need to be using the more difficult equation. I've been trying to figure out why it's one way and why it's the other way. I'm not quite sure yet. Maybe we need to email the TA and be like, okay.
I think we start using n in the complex equation whenever we have like a parent population. So you have
But they all have a parent population, like everything in the bell curve. That's our, I don't know.
So what is key, and it's helping understand, is that the N stands for the number of observations, and we are looking for the distribution between the means in a sample mean, in a sample, not in a population.
Rather than in a population mean.
Yeah, the formula we're using now is for the distribution of the observations in a population. The other one is to find the distribution of the observations in a sample. It's more in detail. Yeah.
Okay, Trent, give us E.
Okay, so I'm getting the second z-score. So it seems to be negative 0.4. And you subtract the 2, correct?
Mm-hmm.
So it would be negative 0.8.
Huh?
So for the z-score, the likelihood of getting of 8, I had negative 0.4,
Yes.
and the z-score for 12 is 0.4.
Yes. One of the things, I kind of went through this with my dad this week, and he made me draw it out again. Notice, since 8 is the mean, I know. Yeah,
10
8
is the mean.
So,
Okay.
no, 10 is 10 is, okay.
That's the mean.
8 is 2 minus the mean. That's what I wrote down. 8 is 2 minus the mean, and 12 is 2 plus the mean.
Yeah.
Which is why it's all, so I've noticed that he was telling us that, like, I don't know, first week or the second week, that we need to make sure we draw things out. And I've noticed it's a good way to kind of check myself to see if my answers make sense. Is even if it isn't part of the question asking me to draw it out, that sometimes drawing it out makes sense.
Yeah.
So since 8 is 2 minus the mean and 12 is 2 plus the mean, it starts making sense that this is more than one standard deviation away. I think it was close to 2, actually. Yeah.
Okay, so you wouldn't just put in negative 0.4 into the applet.
Oh, yeah, you can. Yeah, you put negative 0.4, and then it's going to automatically give you the positive 0.4.
Yeah, and that's giving me an area of 0.6892.
Now make sure you have the right parts highlighted, because it's less than 8 and greater than 12. So the center highlighted. So
less than 8 and greater than 12. That would be the 2. Wouldn't that be the 2 sides?
tails.
Leaving.
Yes.
Yeah, the 2 tails.
Mm-hmm.
So the applet's giving me an area of 0.6892.
Mm-hmm.
Is that correct?
Yes. Now in his answer key, he actually had us, he figured out all of the left side all by its lonesome. So the z-score of negative 0.4 gave you a probability of 0.3446. And then again, did the right side all by its lonesome, positive 0.4, probability of 0.3446, and then added them together. But with the applet, you don't have to do that. But I kind of, as mental math, I made myself do that to remember it's the 2 parts.
Okay, yeah, I see that in the answer key now. And so he took the area from the applet and then he took the 2 areas and then added them together manually.
Yeah.
Okay.
Which I suspect mean, like, because when Anetic was talking about what if they don't match up, that was probably part of this, because I suspect eventually they're not necessarily always going to match up. So we'll have,
So I
you know,
can't trust the applet.
so doing the extra step while it's still simple is probably a good idea.
Yeah. Okay. All right.
Kinetic, do you want to do 4?
Yes. Okay, suppose parallel computer installed an average of 45 p phones per minute in 2011. Yes, that means they sold 23,652,000 p phones in 2011 with a standard deviation of 10, and they look at their p phone sales data and determined that they were normally distributed. Samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X?
Normal.
Yeah.
Because it's
Yeah.
from a normal
I
population.
have started kind of saying out loud to myself as I'm reading the information, n equals 4. Okay, that's a small sample size.
Yep.
You know, taken from a normally distributed, okay, so it doesn't matter that it's a small sample size because it's normally distributed sales data. Like I've started kind of in my mind saying those sort of things out loud.
Yeah. Let me try that with 5. So it says sample size of n equals 40. So that would be a large sample taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? It's normal as well because the sample size is large.
And it's still normally distributed.
Yeah.
When it's normally distributed, the sample size doesn't matter. But when it's not normally distributed, it needs to be a large sample size for it to become approximately normal.
Mm-hmm.
I keep talking it out loud. I'm sorry if that's too much.
There you go.
All right, 6. A sample size of n equals 4, so small sample size, taken from normally distributed 2011 sales data. What is the probability that the observed X is less than 40? So in the question, we were given an n. That's a clue to me that we have to use the more complicated
Z-score function.
Yes. So I just copied from his answer key the z equals x bar minus mu over sigma divided by the square root of n. And then I go back up to the beginning of part 2, and I just, on my left-hand side, I just write down n equals 4. Mu equals 45. Sigma equals, I just look for all of the things that are going to go into my, and just in a column write them all down.
What is less than 40? And so in this case, we don't have n. No, we do. Never mind.
Yes, we do have n.
4.
So we solve for 40. We don't have to worry about the less than 40 until it's time to highlight stuff. So z equals, open parentheses, 40 minus 45, close parentheses, divided by
10.
Yep, 10 divided, all divided by the square root of 4, those parentheses.
Five divided by 10. 0.5. I don't really know how to do the square root function on my little calculator. I know it's 2 anyway, but
I've been doing it in Excel.
Yeah, I'm pulling Excel up now. You know, in the quiz, it just says, did you finish your preparation assignment or not? I appreciate the help, but maybe we don't have you. Maybe we should just do the quiz together,
Okay.
and then I'll have to figure it out just like y'all did,
Okay.
because I don't want to waste y'all's time.
Let me talk out the rest of 6 though, because I noticed a couple of interesting things.
Okay.
So ultimately the z-score is -1. So that means it falls right on the first standard deviation, -1. That means the probability, just for my mental math, that means the probability has to be approximately 16%.
Mm-hmm.
If you subtract, the 68, that leaves you with whatever, 100 minus 68 leaves you with the 2 outliers, and then cut that in half gives you approximately 16%. And once you throw the -1 into the applet, it gives you 0.1587, which is approximately 0.16 when you round up.
Mm-hmm.
So that was one of the ways that I was using to kind of double check myself to make sure I was getting in about the right area. So if it fell on the first standard deviation, I knew it had to be about that. If it fell on the second standard deviation, no, walk away. It had to fall under the approximately, 95%, and then the third standard. So those standard deviations give us a nice way to check ourselves if that's where we're playing.
That's why you were drawing them out.
Yep.
Okay.
Okay, and then the rest of them, he was just making us kind of check. So for 7, even though the sample size n equals 4, okay, small sample size, but it's still okay because it's normally distributed data. But when we get down to 10, sample size n equals 4, okay, small sample size, but it's right skewed data.
Mm-hmm.
So it's not normal. Now the question is, what is the shape of the distribution of the mean of the sample? And then it's right skewed because the population is right skewed and the sample size is small. So our formula wouldn't work because it doesn't fall under the central
Normal
limit.
distribution.
Yeah, because it doesn't fall under the central limit theorem. It's okay if the population is not normal as long as our sample size is large. If our sample size isn't large, until we learn more, apparently, it's beyond our capabilities. Okay, you said you just wanted to get to the quiz. Do we want to just get to the quiz then now, or are we okay?
Yeah, if y'all have already checked your answers for part 2, I don't see anything in the instructions saying that. Yeah, I'll just have to mark that I didn't finish them on the quiz. But I appreciate the help. That will definitely help me figure out the rest of them. But I don't think it's fair for y'all to have to teach me the stuff that y'all figured out on your own. So
it doesn't
I'll
hurt to
get
have
it.
to, I was going to say, it doesn't hurt to have to go through it.
Yeah,
Okay, shall we all start the quiz then?
yeah, I'll pull it up now.
Sounds good.
Anything good?
Yeah,
Okay,
I'm working on it, trying to find it.
I'm opening the stuff. Yeah, while I was doing the homework, I thought I'd made a bookmark for the probability applet, and the bookmark like disappeared, and I couldn't remember where it was in our book.
Ooh.
Yeah, it was bad. So I'm going back through the history. It's got to be in here somewhere. It's got to be in here somewhere.
Oh, your browser history?
Yeah.
Yeah, that'd be frustrating. I've got mine as a favorite, but they just updated to Windows 10 at work, and I lost all my favorites. So I wound up, having to figure out how to find everything that I need.
Nightmare.
Yeah, in Windows 10. I can't even figure out how to get to my computer on Windows 10. So I'm gonna have to Google. I'm gonna have to find a YouTube video.
YouTube or something. Yeah.
Yeah.
Okay.
Question
Annette,
3.
who wants to go first?
I'll read it. Okay, number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z-score minus 1.358 and to the left of the z-score minus 1.358.
Okay.
So positive and -3.
It's just the wings.
Yes.
So I got 0.745.
I have 0.1745.
Yeah. I misspoke.
Yeah, and they've got put your answer to only 3 decimal places though. So we got to round up. So it's 0.175. Right?
Yes.
Yes.
Okay.
175.
Question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population?
We'll have a smaller standard deviation.
If 9 observations are randomly drawn from the population. The distribution of an individual observation, X. The distribution of sample means, X bar. This cannot be determined from the information given.
Which of the following have a smaller standard deviation? I think this distribution of an individual observation would have a smaller standard deviation, but maybe not necessarily.
I think for number 4 is the second one, the distribution of the sample means. Yeah.
Because there's only 9 observations, and they're finding the mean of those 9 observations.
It seems like if you had 9 observations, though, it would smaller standard deviation.
So if the observations are close together, then the standard deviation is
Smaller.
smaller. So it can be the same number of observations.
But,
Okay.
but since we don't know what the 9 observations are, can we really determine this information? I guess is what I'm kind of thinking.
Which of the following will have a smaller standard deviation? Randomly drawn. What would the standard deviation of just an individual observation look like? You would have the mean.
I'm not sure there is a standard deviation for just one observation.
That's true.
Yeah.
So it's either C or B or C
Yeah.
distribution of sample.
And since we don't know what the standard deviation, yeah, we don't. I really don't think we can determine it with the little information that we've been given.
We just know that there are 9 observations.
Randomly drawn from the population. Yep, that's it.
So which one are we choosing?
I marked C.
I'm going to go with C. This cannot be determined with the information given. If you want to go with B, we'll figure out who's right. All 3 of us know that it's not the first one.
Yeah, I go with C and see what happens.
Okay, which of the following results implies that the spread in X bar decreases, or is it bar X? X bar decreases as the sample size increases. The mean of the samples decreases as the sample size increases. I think that's the law of large numbers. Where's my thing?
The law of large numbers is that the population mean comes closer to the sample mean, the bigger the sample size, I think.
The spread in the sample mean decreases as the sample size increases. As the number of repetitions increases in an experiment, the proportion of the outcome observed gets closer to the probability of the outcome. Okay, so maybe it's not that.
So what I have for the law of large numbers is that the mean will typically be close to the population mean, or mu. So if it's a large
Sample size is large.
If the sample size is large, then that's gonna then X bar will be close to the population mean.
Okay. So implies that the spread in X bar decreases as the sample size increases.
I think that would actually work. Because if X bar is closer to mu, then that means that the data is less spread out.
What do you think, Kinetic?
Hmm.
Anybody have the central limit theorem somewhere handy?
Yeah. Basically, if the sample size is large, the distribution will be normal. That's what I have for the central limit theorem.
But from what I was saying, that if we have the standard deviation decreases as the samples are close together, get close together. So
So is that just normal distribution? Or is that the 68, 95, 99.7 rule?
Implies that the spread in
I would say this is the central limit theorem.
You think it's the central limit theorem?
I think so.
what's the official? Does anybody have an official definition for it? Because I have my version.
don't think I printed it out.
Because the central limit theorem says that if we have a larger number of observations, we're going to have a more normal distribution, right?
Yes.
So that's decreasing then.
Decreasing
That's
the mean.
getting closer. It's getting closer to the normal distribution. So
Okay.
we would say it's that one.
Yeah. I just remember that the law of large numbers is about accuracy. So maybe that makes sense that this is the central theorem. All right. Got to do a better job of understanding those two.
6. Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mu equals 150.8 and the standard deviation equaling 8.8.
Yes.
Deanne earned a score of 160 in the quantitative portion of the GRE. What is the z-score corresponding to Deanne's score? So we got mu. That means it'll be the complex
We don't have an n,
score.
so that's the simple one. So z equals, actually don't get this backwards, x minus mu divided by sigma, with x being 160, subtract mu 150.8, all divided by sigma 8.8.
So 9.2 divided by 8.8. Okay. So I got 1.045455.
Yeah, that's what I got.
Okay, round to 3 decimal places. So 1.045. Which means it's almost at the first standard deviation.
How is it again that you can tell how close it is to the standard deviation? The first?
Because if it's the standard deviation, it would be 1 or -1. So
this is greater than 1 standard deviation, right?
just by a hint, 1.04.
Yeah.
Yep, just by a little bit. I just put it into the applet. All right. Number 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So that would basically just be the area,
Yeah. So,
the right wing.
yep.
It'd be 0.48. 0.148.
1.05.
0.1.
and then only the right side highlighted. So the probability is 0.1480. Is that what you got?
Yeah, that's what I got.
And again, 3 decimal places, so 0.148.
All right. Who wants to read number 2 or number 8?
8. I can do it. Oh, and then actually, Annette, I think it's your turn.
Okay. Okay, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the Z-score corresponding to the sample mean of these students' scores? So we have to use the more complicated equation, right?
No, we just have to find the mean of the
Okay,
scores and then find the Z-score.
but it says sample mean.
We're creating a sample mean by adding them all together and then dividing by 5.
And then solving for Z.
Yes.
Okay.
60 plus 75 plus 3. So I got a sample mean of 160.
So you added those numbers, then got the mean.
And then then divided by 5.
Divided by 5.
Yep, because there's 5.
And,
Yeah.
And then
Our sample mean is now 160. And
okay,
go back up to the
formula for the equation.
So mu is 150.8. Standard deviation is 8.8.
A random sample of 5 students was selected. I'm still not sure I understand the question.
Okay, so they're asking us to make up our own sample mean, which would be the X bar, and then find the Z-score. So we're basically just adding one more step to what we did up in, I think it was 6.
Okay, so I've got the new sample of means, which is 160
Yes,
minus
150.8.
okay, and
In parentheses,
that information
yeah. In parentheses
is
divided by 8.8.
okay. I see. I was just a little lost without the
So I've got it.
without the information up above.
Gotcha.
$150.8.
So I've got a z-score of 1.04545 again.
Yeah, that's what I got too.
So rounding it to how many decimal places? To 3 again, 1.045.
Yeah, I got the same.
Okay, I think now, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So we put our z-score in again, 1.045. Highlight the right side only in the probability applet. And there's only a 0.1480 probability that anyone will get above 160. And they want 4 decimal places this time.
I want 4.
0.1480.
0.
So use the following information in the next 5 questions. All right, Trent, you're up.
Okay, I'm saving the last one. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of 81 students who are selected?
Okay, so
I'd say
let's stop for just a second. N equals 81, so that's
it's a large.
great. Yeah, so large sample.
It's approximately normal.
Yes. So because of the central limit theorem, it's approximately normal.
Mhm.
All right. So what is the shape of the sampling distribution of the random sample? So it has to be approximately, yeah, you just answered, it's approximately normal, sorry. What is the mean of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population?
So that's x bar.
Yes.
So here's where we're gonna use the more complicated equation.
Yes.
All right, now what's mu?
I
I
think
think we're just solving for x. It's 3.5.
yes, mu is 3.5. Sigma is 0.7. N is 81. So what is the mean of the distribution of sample means? Okay,
Okay,
class, not your turn.
so
Out.
so I think the answer for this one is the mean. It's the same mean that they gave us above. Would be 3.5. That comes from the parent population. It's the same. What changes is the standard deviation.
Because of the central limit theorem. It's approximately this, so the sample mean is approximately the same as mu, which is what they gave us because of the central limit theorem. Yes. So it's 3.5.
You sure we're not just calculating for x bar?
But we don't have a z-score.
That's true. We're missing two pieces of the equation.
Yes.
Okay.
He's making us think through the central limit theorem states that if your sample size is large, which ours is, it's 81, it doesn't matter that it's, is it right skewed?
Yeah, I believe so.
It doesn't matter that it's distributed as left skewed. The mean of the sample population will be approximately the same as mu.
Okay.
So it's 3.5.
Okay. I got number 12. It says, what is the standard deviation of the distribution of sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? Would that be 0.7 divided by the square root of 81, which is 9? Because we can at least solve for the standard deviation.
Yes. So 0.7 divided by the square root of 81, which, like you said, so 0.7 divided by 9, which gives us what?
Point 0.077778.
Okay, so 3 decimal places, 0.078. So, sorry, 0.078. That makes sense, Anetic?
Hold on just a second, I'm trying to figure it out. Okay, I think I'm not understanding this question.
It's just the bottom part of the z-score. 0.7 is the, at first I thought it was just going to be 0.7, but it's sigma divided by the square root of n. So,
Okay. Okay, yeah, it makes sense. So that would be so I got 0.0777.
but we have to round it to 3 decimal places. So it's 0.078.
Okay.
Okay, so for the next one, we've got to calculate the z-score first. So 3.3 is the X bar. Mu is 3.5. Sigma
Divided by
0.7 and N is 81. So 3.3 subtract 3.5 divided by 0.7 square root of N divided by square root of 81, parentheses. Okay, all right. I've got 3 questions left. So all of the burrito shells in the freezer, there's little cups on the table. Have Quinn help you get extension cords and the turkey thing. I'll have to move the van out so we can get the tables. Take my phone. Here's a list of the stuff. Because I gotta finish.
Where are the burrito shells?
In the laundry room freezer.
In the laundry room freezer.
All of them that are in there.
Okay. It's like Bronwyn's
Yeah.
husband or something.
Yes.
Thank you.
Extension cords, table roaster. I'll have to get the wallet, and you have to get the tortilla shells and the little cuppy things.
Where are the little
Sorry.
things?
On the dining room table. It's in a package of 50. Sorry about that.
you're good.
No worries.
So I got roughly, it's can you get a negative probability? It's a negative z-score, right?
Yeah, it's a negative z-score.
All right, negative 0.031785.
It's the z-score, and then we have to put it in the applet. So give me a chance to catch up to you guys.
So yeah. So what do you get for z-score, Trent?
I got negative 0.03175.
Let me try again.
So negative 3.3 subtract negative 3.5 parentheses divided by parentheses 0.7 divided by square root of 81. So your z-score is negative 2.571. Is that right?
I got a negative 0.03175.
For your z-score?
Yes.
Okay, so I've got
Right.
z equals parentheses 3.3 subtract 3.5
3.5.
close parentheses divided by open parentheses 0.7 over square root of 81 close parentheses.
Yes, that's what I've written down too.
What
Okay.
did you get, Laura?
Hold on, I must have done it wrong. And I got negative 2.57. I did this wrong, I think. Let me do the square root first.
Good.
I'll do 2 more steps. Square root of 81 is 9. 7 divided by 9. 8. 3 subtract 5. That. I still get negative 2.5714.
Okay, I did the steps individually. I subtracted 3.5 from 3.3. So 3.3 minus 3.5 equals negative 0.2. And then I divided that by 0.7, which gives me 28571. And then I divided that by 9, or the square root of 81. But let me just try to set up the equation like you had it.
I've done it 3 different ways, and I'm getting negative 2.5714.
Yeah, that's what I got last time, but I'm trying again. Let's see what I get.
I have to step away for a minute, gentlemen. I'll be right
Okay.
back.
Yeah, go ahead.
Got someone picking stuff up.
Okay, I did it the way she set it up, and I did get negative 2 point.
Okay. I'm trying again, but that's what I got last time. So so what you got, you said?
I got the same answer whenever I built the equation like she did, but I'm still not sure that's right.
I got minus 2.87. No, it's 57.
Negative 2.571.
Yeah, that's what I got too.
It doesn't really make sense though, because it's almost at the third standard deviation. And the question is, what is the probability that the mean GPA for 81
Will
will
be
be
less
less?
than 3.3.
It just seems like a really low probability. That's 0.5% probability that they would have, that 81 students would have.
Well, remember, you're on academic cap if you get a C. Okay, so do we end up with negative 2.571?
Yeah, when I did the equation like you had it set up. So I probably just built it wrong.
So probability of 0.010.
Yeah, 0.0051. How many decimal places does it say to round it to?
3.
3 decimal places.
So I've got 0.010.
0.010. I got, whenever I put in the the z-score into the probability applet, I got 0.0051.
Oh, wait a minute. I've got both sides highlighted. I
Yeah,
didn't
that's what I got.
left side. There we go. I only have the left side highlighted at 0.005.
All right, I guess we can try that. 0.05.
Must be really tight in the GPA department. Okay, and then
Yeah.
because we've already worked it out, what is the probability that the mean GPA for 81 randomly selected students will be greater than 3.3? So we highlight the center and the right and unhighlight the left. It's 0.9949, so 0.995 because we're 3 decimal places. Does that make sense?
Yeah. Well, not really. I mean, it makes sense on the applet, but
Anything less than is to the left of that red line for 2.571. Anything
Okay,
bigger
so
than, everything to the right.
so I just and I understand something. So because we got a z-score of minus 2.57.
2.571.
And in the last,
Yes.
yeah, and in the last question, we were looking for the probability of getting something greater than that.
Yeah.
So we had to.
Less than 3.3 is.
So that was the first question, right?
Yes. Less than 3.3
So,
is 13. Greater
okay.
than 3.3 is 14.
And we had to select the middle and the right because we are looking for a negative z-score.
Positive. Positive. Anything greater than that left line is what we're looking for.
Okay. If the 2.75 score was positive, then we were looking for something greater than that.
It would only be that right tail.
Okay. So that was confusing for me, but now I understand that.
I don't remember whose turn it is. Sorry, guys.
I think it might be mine. It says the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. So we're looking for the p-value. Or the z. The p-value is a probability that something as extreme could occur by chance.
I'll get there in a second. So the mu is 185 pounds. And the standard deviation is 26.7 pounds. So sigma is 26.7. The random sample of 48, so that n equals 48. So x bar is 177.6 pounds. So find the probability this normal probability applet. All right, so find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than observed in the sample. So greater than 177.6.
It says either above or below the mean.
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So the same or greater than 177.6.
Okay, so Laura, you said that the mean is 185,
Mu.
right?
Yeah, mu is 185.
But as we read, this says that the previous value was lower. So I think they changed that. So
Yeah.
now the mean is 175.6.
No, the sample mean. X bar is 177.6.
But the sample mean and the population mean is the same, right?
No, not this time, because we're going to find a z-score and then plug it into the probability applet is I think what we're doing here. The mu is now 185. It used to be lower. They're just telling us in the old days it was different. I think that's kind of irrelevant. The mu is now 185. Sigma is, yeah, 26.7. Sample mean, so that's X bar is 177.6. I think we have to use the simple z-score.
I don't know. We have everything for the
But we
complex.
have an n. Yeah, so I guess we just use the whole, so z equals 177, I'm sorry, it's being loud. So z equals 177.6, subtract 185 in parentheses, divided by 26.7 over square root of 48.
Yes.
Okay. No. I'm busy. All the other stuff from before. I have a z-score of negative 1.920.
That's what I got as well.
Okay, so we plug it into the applet. Negative 1.920. And then we want as extreme or more extreme. Means that we are not only interested in the values that are lower than the ones we observe, but also the values that are far away from the mean. So I think that means we highlight the center and the far right.
Yeah.
So I have a probability of 0.9726. But they only want 3 decimal places, so 0.973. Does that make sense?
Yeah. Once again, like that's a 97% chance though that you can find a random sample that extreme.
More than
I know.
170.65, more than 177.6 pounds. But since the population mean is 185,
It would
kinda
be
makes
almost all. Okay. Yeah, that does kind of make sense.
because we're looking at basically 2 standard deviations.
Below the mean.
Yeah, below the mean. Just inside of it looks like. So
All right.
we hit that
Just inside the second deviation.
yeah. Which is basically the center is 95% almost, and then plus the little bit on the right. So 97, just shy of 97% makes sense. Or a little more than 97, actually, I guess. Okay, are we submitting our quiz?
Yes.
Yes.
All right. Let's see what the damage is. No, we missed 4
And 5.
and 5. It must have been the law of large numbers. Really? Oh, crap. Hmm.
Eight, 9.
And 15.
Okay. Well, looks like we're retaking it.
Yeah, but I don't.
Okay, I'm gonna write down the answers we got correct as well real quick so we don't have to think about those again. But you've got dinner on the table, right, Laura?
Actually, I have to make it, and then I've got Relief Society. I'm going to take note of what we got right, and then I'll have to just come back later and do it. Do you guys want to just? I'll stop recording, but I won't close it out. Can you still stay on if I'm just not recording?
Yeah, I think so.
Okay.
I actually had to go, but we can retake it now. By yourself, right?
Yeah, just retake it ourselves. I'm going to go look up all of the, like all of our laws there, 68, 95, 90. So I'm going to look up all of those rules and see which one. I think for question 4, then it must be the distribution of the sample means, because I don't see how you can have a distribution of an individual observation.
Yeah. And for the last one, number 15, I got really confused. So what was the equation you used?
We use the sample means z-score, the complex z-score
Okay, what was
equation.
the numbers? What numbers you guys use on top, like numerators?
X bar is 177.6.
Okay.
Mu is 185. Sigma, or standard deviation, is, so the population mean is 185. Standard deviation is 26.7. and N is 48.
Okay.
I wonder what I was doing wrong.
Okay.
All right. I will have to
We'll,
check
we'll
this
figure
later.
it out.
Thanks, guys.
Thank you.
No
I'm gonna
problem.
stop
See
the
you guys.
broadcast and I'll attach this later, and I'm just gonna leave it go and hit mute. See ya.
See you, Laura.